Okay, so hang on, I'm not sharing screen, right?
Yeah.
It says join meeting here. That means that it kicked me. Oh no, hang on, that's probably the wrong. I'm in the meeting. Yeah, that's right.
Yeah, the projector is on.
Good. So I'll share my screen. So good luck. Right. So who of you has to this morning created their first web API in their life? Yes, good. Some of you, great. Well, great experience. This is, you know, these are these things that you want to basically take the magic away from. And but I had an interesting discussion over the coffee break also that this is indeed a way to sort of this plumber looks odd, like why do web APIs in R, but it's a way for managing, right, for managing operational services through organizations, and APIs are important there. All right, so we're looking now at the I got a very pleasant email at about 10 o'clock that Cloud has increased my or refreshed my account and the number of credits that I can do. So apparently I can do something again. This is really great. Fantastic. So it's so easy to run out of or whatever. I had this this free account, and so I will just quit this RStudio session again and show how things work. So we are going this now this afternoon through 3 examples that use OpenGeo backends, and we're using the R client and hopefully also the Python client. Just let me just quit this and see if everything is gone. Don't save. Why would it save? Thanks. So this file looks slightly different from the one that you may have downloaded, but not seriously, because I tried to solve all kinds of things this morning just before breakfast, and then failed and decided to have breakfast, which is, I think, a good life decision always. So we went through this, how it works. And so now we get into the examples. This is probably not readable, right? When will it become readable? Is this readable in the back already, or should I? How is this? Okay, great. Fantastic. Right. So I don't know what this does. Why this is here. We are going to so we can skip this. This is a little bit a piece of code that is there. The authentication system is interactive. It sends you to a web browser to do the authentication in the web browser with this OID, whatever system. And if you then do a batch process, but I do constantly batch process my R Markdown into an HTML and push that to GitHub, then that doesn't work. So we have to fool that. We have to save the connection and then reload it and then skip the interactive login, because I can't, if you do a batch process, you can't do an open. So this says, okay, do I have a connection? Yes, I'm going to run this and see. So you can see that we're now interactive. I load library OpenGeo, which is an R library. I create a connection to this server OpenGeo Cloud. OpenGeo.cloud, and it says here, okay, this is the connection OpenGeo Cloud.vito.be, so you can see this runs at Vito, right? You can then do a couple of things, term of service, privacy policy, and so on. And it says our host is not production ready. Whatever that means. Next, we can log in. We don't have to log in. We can also postpone it until the really latest stage, when I ask for processing to be done, as I mentioned earlier, right? But let's postpone it to the end. Let's see. So that should be, I think that should be here when I say compute results. There I have to log in. I'm not going to log in so far. They don't know who I am. So we are here. And I'm going to, so I have this connection object, which is, of course, probably not, oh, it's a JSON object, whatever. I'm going to load here the processes. And you can see that takes a while because there's a lot of processes. So it now queries the connection that I opened. So it stored this connection somewhere and can use it. If I don't specify a connection, I can specify a connection by an argument, but it uses the one that I have opened. And I can, in principle, query this. And you can see here that this is a long sort of list of, you see all these processes here mentioned. Yeah, briefly mentioned their title, and then basically their header, you know, as it looks like. So you can see for these processes in this process object that these are all functions. And you can see the argument names, right? And they correspond actually to the argument names in the API, and they correspond also to the processes that this server offers. Yeah, there is the list of processes that the OpenAPI defines, that it says these are possible processes, right? It's not given that any backend you connect to has all of them. There you may connect the backend that only has one of them or two, right? So by loading the processes, you load the processes from the backend. It queries the backend and gets all the processes back. And by working on this object, essentially the way you work with Python objects in R, you can basically constrain yourself to writing code that will work, yeah, because you are basically now doing things next. For instance, here I will skip these two. Here I say load collection, yeah, but I say $. That means I'm using the function here that is a member of P. These are these R6 objects that work like Python objects. Yeah, so think Python p.load collection. That is how it will look like in Python, I guess. Yeah, so I know, of course, load collection should be always present, but I now make sure that basically by using the functions in my processes object, that I have functions that are provided by the backend. Here, the next step is list collection. So I get a collections list, and query that collections. And here you see that this is a pretty long list. So it's a table. It's returned as a table with 133 rows and 4 columns. And you can see that it has ID, it has a title and a description. And we only see the first 10 printed, but we can, of course, query all of them and ask the collections 122, for instance, and see what that is. Oh, this is apparently not entirely a table, but it's a collection list. Okay, maybe then I should then ask for list member 122 and see what that is. Oops. And then it gives me a collection 122, which is, it gives the full description here. So this is Sentinel 5P, CH methane into Sentinel 5P. So this is atmospheric chemistry data, Sentinel 5P, and gives the description, Sentinel 5P uses blah, 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 and so on, right? This is sort of a little bit hard to digest and search. And for that reason, there is also an integration with RStudio here, where you can look at the collections that a backend provides, and they are opened essentially in a tab like this, right? I think there is also a way that I can open a tab with the processes and get the process listing in a way that I can sort of browse through them interactively. But this is a way where you can see how the, where the what the collections are, what they are called, and what is in them. Sentinel 2, level 2A from SentinelHub. Yeah, that's the level 2A data that are apparently provided by SentinelHub. So this is a stack. This is a sort of comes from a stack interface and provides that. So you see the extent here, the temporal extent from when to when are these data available. There it is a null with the extent. So that's probably indicating that it's continuing. So it is up till, as recent as possible. And then it has a global extent in a certain latitude band where Sentinel-2 measures. Sentinel-2 does land, right? So it's not doing sea, and apparently not Antarctica. So we have list collections. Then we can list the file formats. Yeah, that is useful to figure out if you want to have a netcdf and your backend cannot write netcdf. So the formats. You also have to pass a format object to the format writer that says which formats can you do. Here it says .cdf. Here it says PNG. It doesn't sound very useful. JSON, JPEG, GeoJSON, and GeoTIFF will also be one of them, I guess. I'm not sure, by the way. Then we start doing a process. So we create an object S2, which calls load collection, and which loads a collection and defines a spatial extent. So you can see here that I have an extent. So I made it pretty small with a 0.2 degree. So that is roughly 20 by 20 kilometer or something like that. And I have a temporal extent from January 21 to January 21. So that is for 1 month. And I limit my bands to band 4 and band 8. Yeah, this of course assumes that these bands have these names, and there are, there are always like incompatibilities in that sense. Like, is band 4 always B04 or B04 or B4 or band 4, or all these kind of things are always challenges in data collections, that the standardization of the names is Sentinel-2 called Sentinel-2 or S2 or whatever, these kind of things. But these are issues that once you start, and then of course if you have these issues, two backends both have Sentinel-2 but give them different names, then you see that, right? Then you run into that, and then you can start thinking about, can we maybe solve that, or can we maybe sort of abstract on top of that or something, do something with that. So this is just, let's say, a scope and load collection, scoping of what is my spatial extent and what are the bands that I want to work on. Then the next step is that I want to do reduce dimension, and I work on the data S2. So I work on the sort of the selection that I created, but I'm going to reduce a dimension. Dimension I'm going to reduce is bands. So we talked about reduction of dimensions yesterday, and I'm going to do a computation on that. And the reducer is this function, yeah, and that looks like an R function, yes, and it is actually an R function if you see it like this. Now what this does is so first of all we take the reduced dimension, which is a member of this P object, so we know it's a function available. We define a reducer here on the fly. We say band 2 minus band 1. So these bands should be band 8 and band 4. So that is the difference between 8 and 4 divided by the sum of 8 and 4. So that is what we do with an NDVI. This R function is not, let's say, is not pushed to the backend as an R function. No, it's being evaluated, and it looks and it says, oh, it does a minus here. Minus is a process that I know. Oh, it does done a plus here. Plus is a process that I know. Oh, it does a divide here. Divide is a process that I know. So it looks at the expression tree and converts that into an OpenGeo process graph, yeah, into something that is independent. So it's not like the backend is going to run R. No, the client is interpreting the R function and understands all the symbols in it and converts that into an OpenGeo process graph, which is also an expression graph with divide through two things, minus 8 and 4 plus 8 and 4, right? That tree, that's the graph, that's the expression graph. So that's what it does. It's here, it looks like, oh, I define an R function. No, it's interpreting the R function and converting it because it can. It can, of course, only if all the things happening in this function are understood, are processes, like minus, plus, divide, right? Sinus will also work, but if you say compute breakpoint using BFAST version 3.5, yeah, then it will not understand, right? Because that is an R function that's coming from somewhere. So that means your ability is limited. But I will talk about user-defined functions later. So these are a lot of functions that use the OpenGeo operators, can be interpreted and can be translated into a process graph, into an OpenGeo representation, with the advantage that the backend can do these things then efficiently as it thinks is good. Next, I then have basically a time series of NDVI, right? So I reduce my bands dimension. I have a single band, a single variant sort of NDVI band now. And then I want to sort of get rid of my time dimension. And I'm going to say, do a reduce dimension, but now reduce over time. That means loop over time, take all the values for a time series of my data, which is now the computed NDVI values, and take the maximum. And max is another function that OpenGeo understands, and that is converted into an OpenGeo process, the max process. Melita.
So this point after $3,
yeah,
that's the functions that are defined on the what is it called, servers
backend. Yeah, on the server, right? That is so if you call on $P with a function name that is defined as an OpenGeo process on the OpenGeo software side, but not sort of exposed, not provided by the server, then you will not find it. Yeah, as if I have a yeah, that the documentation shows all possible functions. Yeah, and here you have basically in the P object you have all available functions, which is necessarily always a subset. Like I think I can get them by maybe by namespeed, right? So we get sort of, you know, we can look at all the functions that P has. And I think there is also one of these tabs that I can open. I just don't know how it works. I'm sorry?
They're now also in this OpenGeo library.
Yeah, but they're loaded dynamically. You can see here that I created the object P by asking processes from the server. I can only do this after I connect it to the server. Here, I have an open connection. I am connected. I'm not authenticated yet, but you don't have to authenticate to find out what the server has and can do. You only have to authenticate when you want to do something, when you want to compute. So we have P, and it's a little bit confusing that P doesn't take the argument con. Maybe I should do it like that. Processes. So you can see that processes takes a connection, right? But if it's null, then it has its active connection. It has an active connection sort of stored for you, yeah, which is a little bit. Well, that's only a warning. It's only a warning that you can ignore. It's just sort of a no warranty, you know. Don't shoot at us if it doesn't work. You know, don't say you were not warned that it wouldn't work. No, it's a warning. It would be an error. Yeah, there's a difference between that.
I see somewhere documentation for this function for those importance. Like I can see that we can see the arguments, something where it's more documented.
Well, that is no, you cannot. You can if you go to this website, right? Yeah, processes.openio.org, which is the formal API processes definitions. There you get the processes complete functionality. I don't think we can get, oops, where am I? I'm in our studio. I said process is the function I get, but I can't now have like P, you know, P sinus will exist. But I don't think that there is documentation for P sinus. If I ask question mark P sinus, you know, that doesn't work. So you have to go to the, if you want to understand, you have to go to the thing, you can, and then you can search here and search for sinus. There's a lot of things that pop up, but here is sinus, and it just, you know, sinus of number. So whatever, if you throw in a data cube, then it will compute the sinus of of all the pixels of the data cube. This is one of these element-wise operators. So that is somewhat, you know, hidden. It is it's pretty hard to drag in the entire. So we can drag in the arguments and types, but it's also never evaluated here. So whatever I do here, whatever I've done so far, yeah, and I don't know where I was with in terms of the things that I did. I said load collection. I think I didn't execute this one, right? So let's execute this one. I still haven't done anything. Yeah, I'm only building a process graph. There's no computation going on. You haven't seen any computed pixels yet. So nothing has been computed, right? I even didn't authenticate, right? So I don't have it. The server doesn't even know me, doesn't even know whether I am allowed to do that. So I'm just sort of building the program during these steps. Yeah, the process graph, which is the program that's going to be executed. This was my reduce max. I was going to say I want maximum NDVI over this time period, and that takes max, which is also a function that is recognized. Oops, I wanted to do this one. Oh, I'm so clumsy with RStudio, it's terrible. And then I say P export as geotiff, and I say save result. I don't know if this will work. Yeah, it will. It doesn't do anything. It just says that I want to have my results saved as a geotiff, right? And then is the next step is compute result. And there I have to, you know, I can try to do this, but I hope it will fail. Unauthorized. Yeah. I'm not allowed to do that because I didn't say who am I, and they didn't check whether I am somebody who has credits. Now I hope I have credits. And actually Jeroen told me I should have. So let's do the login first. Right. And here you see this copy thing that was in the past. You don't no longer have to do that. In the past, you had to copy the string to somebody else so that it believed you are you. This is no longer needed. We just have to go here to, this is the interactive part, to the command prompt where it says press enter to proceed. I have to press enter. And then it says wait for blah, blah, blah. And then you get to one of these windows, not to this one, actually to another one, but because I just did this in the break, it jumps over the first few authentication things, but it goes to the window where it says, who are you? What is your login sort of mechanism? And that could be your organization. For me, it's my university, and I get to my standard university login thing with my university login names, but it can also be social things like GitHub or whatever, Google or something like that. So any sort of authentication system. This works through EGI, so that has all European research and university institutes in it, right? Connected through that. So it now asks access, and I have to say yes. I first have to say who I am. It still remembered that, and I have to say yes, granted. Okay, device login successful. So I can go back, close this window, and go back to my thing. There it says login successful. And then I should be able to do something. So I'm going to compute result here. And now we have to wait. Sorry?
I got there, like, HTTP more constant than frequent. You can server proper in Rome, and you can open more part of the authentication is required. So I did log in, but when I could do it with compute, then I got this error.
So do you have an account?
I log in with university account.
Yeah, but did you sort of apply for an OpenGeoHub account so that OpenGeoHub knows you and gave you credits?
And it said to write login successful, but
yeah, but it might still, you sort of the login system might recognize you, but then OpenGeoHub.cloud has to recognize you as a user who has credits. Yeah, so the way to do that is to go to cloud, OpenGeoHub.cloud, And then this is the one thing I posted a week ago or so in the channel with the task, like, you know, do this. And here it says service offering, free trial. Yeah, this is where you have to go to and apply for the free trial. I think you can do this now. Apparently this doesn't take any interaction. Yeah, so do it now. It might work in 5 minutes. So this is the current setup how it works now. This says it's valid for 30 days, but also you have some kind of limitation. Doesn't mean that you have infinite resources for 30 days, right? So you have a number of credits, and there are ways to. I'll have to read. I asked that Jeroen this morning. There are ways to check how far your credits are going, so to speak, right? I managed to deplete them this morning with a little script that did the same thing, but then for 100 by 100 kilometer and maybe a few years or so. Yeah, so there's the free trial. Then the other option is that also says free, network of resources sponsoring. Network of resources is an ESA program. So that means if you have an idea of something serious you want to do with this, or if you need more than 30 days because you do research and you need it for 3 months or 6 months, you can apply for different levels of support that then will be supported by ESA. ESA is happy to support things, but you have to go through the little hoop of administration and saying what you're going to do and how much and so on, right? So this is friction, but this is kind of enormously much better than it was 2 years ago, and then it was 4 years ago, and then it was 6 years ago. I can promise you this. Yeah, we're making small steps, but it's significant steps. This is significant that free trial doesn't have to go to a human person sort of looking at this, and you know, the person is on holiday and it takes a week or so. So that is the second thing. The other thing that I noted this morning was it said emails, your credit is at -14 and go here to upload your credit. And I could sort of, you know, choose for plans, paid plans. There was a plan from 1,400 euros. There was a plan for 5,000 euros and a plan for 10,000 euros. So you can burn money here, yeah. And if you want to do commercial things, it might be, you know, I have no clue, but this might be sort of worth it, right? I mean, buying a terabyte, buying a petabyte hard drives and filling them is also sort of an effort that costs thousands of euros. Right, don't have to tell you that. So, okay, we are here. Oh, well, this gave an internal server error this time. Failed to process synchronously on backend Vito. Vault login error command failed. So I get a relative.
It's not production ready.
Yeah, but it has worked for me in the past. So it said syntax error, sequence truncated. Yeah, maybe I made a mistake. Let me just sort of do the whole process in steps again, run the whole chunk. Maybe it'll work. Good. Well, I don't know if it's good, but let's see. Are there other questions that we can, while we're looking at sort of our hourglass, we can spend time.
So when you call it like an R function,
yeah,
does it need to be like an anonymous on-the-fly function that you edit, or can it also, like, can you define specify function beforehand and just call them by names?
Yeah, with the I think with the constraint that I can put the name of a function here, the name of an object that's a function, with the constraint that the function is composed of OpenGeo operators like max, plus, minus, divide, etc., sinus, and so the whole set of operators that this backend provides. Yeah, I cannot, as I said, I cannot sort of point to some kind of breakpoint detection algorithm that loads in 15 other packages first and has to use some kind of T distribution. Ah, here we did. Oh, let's see what it is worked. Yeah, it worked. Look at that. Look at that. Incredible. So it worked. So we should have a plot here. It's just that our studio doesn't show my, it's here. Yeah, so this is it. So I read it. I read the image with, as you can see, it is saved to a temporary file. This is what I asked for. The temporary file is here. Yeah, that is what you do if you don't want to leave trash on your hard drive. In this case, not so clever because it's easily, it's once the R session is gone, the file is lost and so on. You may want to repeat it because it has cost you credits. So it is loaded here and then plotted, and you can see it is here. Let me just do this again. And zoom it. So we have a grayscale image, which has NDVI values, and which is an area of, what was it, 0.2 degrees by 0.2 degrees. So north-south is roughly 20 kilometers. And that's it. What we see is downsampled image. Plot does the downsampling because it's plotting this little thing. So you were thinking, oh, what are these pixels are so large? But that is because plot was plotting to a very small thing. I wanted to plot all the pixels now. Yeah, which takes a bit longer, but there you can see that it's not pixelated, right? These are 10-meter pixels. So they're much smaller than what you see as pixels on the projector. There are a lot of pixels, many more than the projector has in this scale. So I could zoom if I used quantum GIS. I could now zoom and you would see more, but this is R. You see the quantile, the quantile color breaks that I talked about yesterday, which typically is somewhat useful. Okay, so we went through example 1 successfully, in the sense that I get out what I thought I would get out. Let's go to the second example. The second example was a very nice, here is the Python code. Let's do the Python code. Yeah. So the Python code is not in your example because of all the mess I made before breakfast, as I said, but let's see if we can run this in our studio. I have no clue.
How long is it actually supposed to take for the loading process to succeed? Because I'm waiting for 2 minutes and it just still says waiting for response from server.
Did you press enter?
Yeah.
On the prompt?
It's running.
Did it open a browser window?
I'm actually running on the EOLab Jupyter prompt. So I'm actually already somewhere in the cloud.
Oh.
But it seems to take quite long.
Okay.
Still running.
Yeah, then I'm a little bit out of my sort of comfort zone with all the things that you mentioned now. I pointed you to a support platform. Look at this. So our studio is installing Python, a reticulate, which is the R package that runs you. Oh, and Miniconda, look at this. Wow. So I have a Python prompt in our studio. I don't do this every day. But why not today? Let's see. So we same pattern. We and this was the title of the talk, right? I had to do something with Python, which is my, really my. Oops, it's not working. Did I do this? I have to import OpenGeo. Ah, maybe it doesn't have this in Miniconda now. So is there a Python command on the Python prompt to install a Python package? Install? Thank you. Oh, pip on the Python prompt. I thought that pip and
I think you have to forward shift and then pip main. And then split dot main. Like that's. And then I think it goes as a list, and then you have to write down the string there.
like this,
Yeah.
and then quotes.
Yeah, and then I think then it's install. I think maybe you have to separate it into arguments and install the comma.
Like this?
Yeah.
Wow. All right. Well, fantastic. Yeah, so you know, this Miniconda was not my idea, but I think the Reticulate RStudio people settled on doing this. I did it this morning on just, you know, my Python 3 prompt and installed it with pip, and that worked. So we can go there if this doesn't work, but let's try. This did not work, but why not? Now I have to import, yes, sorry. Look at that. Print collections. So here are the collections printed, yeah, the long list. Data cube connection.load connection. So we see here's a connection, and we have dot member function, which is loaded from the server. Same pattern. Don't know why it's not. Should I? So you mean it only loaded this line and then we'll do this and so on? Oh, wow. Okay, thank you. So do the same thing. The edcube.process, we compute NDVI from these two bands. We see that we have a process called NDVI here, yeah, which is slightly different from what R did. In R, I just defined the function on the fly. I could see what NDVI is. Here I call a process called NDVI. It's fine. Ah, here. Right, call the NDVI function, you mean? Yeah. Yeah, okay. So here right, I just did this, right? Yeah. Now I do the maximum over time. And then save the result. So that doesn't do anything. And then authenticate again, right? Oh, it is authenticated. Bam. And create job. And then start and wait. And this has this nice kind of, you know, this starts and then waits. And oh, this was the big one. I forgot to reduce the extent here. This is pretty large. You can see this is a degree by a degree, so that's a bit more. I don't know if I can. Yeah, the stop button will kill the local process, right? But then I cannot sort of do that again. So it doesn't take so long. In the meantime, I can continue doing something else. Yeah. Before we go to the ecosystem data thing. So let's just wait for this. Yeah, I'm not so adventurous today. Yes.
I think you're gonna take like a multi-composite or PBI in this case, or
Right. Yeah, it's taking the maximum. It's computing month NVIs for all the available values. I didn't do an aggregate temporal, so it takes everything in the month it has, like every 5 days. So that is like six images, and computes NVIs and takes the maximum per pixel over time. That was the reduced time with function max. So I get the maximum NDVI over that month. That is hopefully then cloud free, right? I think. No, that's right. That is, you have to look at the processes, whether there are processes associated with clouds, or whether you can pre-select images that have a minimum cloud, you know, or a maximum cloud coverage or something like that. I don't know from the top of my head. There is a lot of talking always about cloud stuff with spectral data, but I don't know how you could do this. That is beyond my. Right. So another example that I would just wait for this is the Python thing. This is important. So there is another example that I will now talk you through without doing it. Maybe we will do it if we got enough time. Let's just try to get rid of this thing. And so we were here, right? So here's a larger example that I actually copied line for line from this blog post that Michael, without the last name, that Michael published nicely a week ago or something like that, that I ran into on Mastodon. And interestingly, he was using the OpenAPI on the Copernicus data, and I didn't even know that worked. So I was really very, very happy to see that. And then I thought, why not sort of try to reproduce it, right? So what I did was he nicely made it reproducible. So what he did was he created with some browser, I don't know what he used, the Copernicus, something browser, and he selected 3 areas, this area, in this area, and classified them by hand, and used that as the regions for which he wanted to compute spatially averaged NDVI time series, right? To see how this is an urban area, and this is I think this is forest, and this was, I think, mice or something like that, or at least agriculture, and he wanted to see how that looked like. So this is very exploratory. He loaded a number of packages that include SF for handling polygons, and OpenGeo and GeoJSON for GeoJSON things, and all kind of things. And then he ran this script. You see these funny fonts. This is sort of the left arrow assignment. This triangle is a symbol for the pipe, for the R pipe. So interestingly, this just works if you copy and paste it. So it looks like this. My editor will never do this, but so he took a time span of a few years and looked at only these 4 smaller areas, and then connected to the open data space, OpenGeo data space at copernicus.eu, and logged in and started to do these processes, right? So this is all exploratory, load the collections. We've seen that, load the list of processes, list the file formats. You initialize, you basically create your processes object, you create your NDVI function, and here are pixels removed that are not classified as vegetation or non-vegetation. So there is some kind of a filtering going on for particular values. This looks like some kind of cloud filtering, right? This looks at the SCL. SCL is one of these layers that has flags for particular things, isn't it? So these are pixel-wise flags that, and we say that we're gonna discard pixels where SCL layer is 4 or 5. Yeah, so that is again an operator you can do. That is just here. And here is a nice function that does this status job. That is the same thing that we see here. Well, nothing is happening here at the Vito backend. Not even, it doesn't even say that it's doing something. It's very nasty. But I got this as I showed you, I got this morning, this little friendly list of sort of job status before my credits were finally burned. So this is an iterator that sort of prints you the status every 30 seconds. Here is a batch job created, so load collection, reduce dimension with the unusable filters. This is the first filter that is going to happen, and the second filter is then there is a mask is produced, and then basically here the mask process is being executed that selects pixels based on the mask, and then reduces by computing NDVI and by computing the mean NDVI over these spatial regions. Yeah, so you see an average over these polygons that are being created, and the result is printed as a CSV file. I've done that, and it runs brilliantly. And here the job is created, and you get this update, and the job, it took like, I don't know, 15 minutes or something like that. The result is downloaded here in a folder results, so you have to have that folder locally, otherwise it will probably fail. And it reads the results and cleans the names for some reason, and that's it. And then we get a little bit R code. This has nothing to do with OpenGeoHub, but it's of course nice that we have our time series data in R now that are being processed in this beautiful graph, really stunningly beautiful graph of the 3 time series over the 3 years, with the forest in dark green and the city in gray and agriculture in yellow. We see that NDVIs are high and sort of bump up and down, but not so much as the agriculture does, and that city doesn't vary much over time in terms of NDVI. Much less. Yeah, so this is all exploratory and just sort of trying things out, but has a couple of other processes that I haven't used so far, which includes the masking of these pixels in the SCL layer, which has flags for particular cases like throw out cloud pixels and so on, or shadow pixels, and which has the spatial aggregation so that we basically remove a lot of noise by taking a region and computing an average in NDVI over that to get a nicer. Of course, you see here that what you see is these smooth lines, right? So the original observations are, of course, the points, which look much, if you look well, then the points are of course much noisier than the fitted lines. But nevertheless, this is a very nice example of using this. Data ecosystem, data space, yeah, Copernicus data space, we have to call it. I have to get used to the name. The login is slightly different for Copernicus data space. I was actually utterly surprised that I could log in here because I've never applied for an account, but it's probably pretty sure associated with this Vito OpenGeoHub cloud. So I guess that accounts for one work for the other as well. I can try to show you this. Oh, sorry. Yeah, so this looks like this. So it knows my email address for some reason and knows a password. I don't know where I got it, but it got that from. But I always say log in, and then it says then grant access. Then who complains? So that worked for me. I hope that works also for you. That I didn't do it, as I said, I didn't do anything. But of course, there are some things I did. Right. So while this stopped, this finished, it looks like. Okay, so we can actually run the other one.
Know how many credits that cost?
I have no clue, but that is something that I asked Jeroen this morning, and actually he said, so I hope he's not watching. I asked whether there's an API call for your credits, and he said, I don't think that there's already a public API for this. We should perhaps consider how we can get you a larger account. Well, that's another thing. You can go to your account on the website. What he says is portal.terrascope.be/reporting. And I'm not entirely sure. Terrascope is kind of a parallel activity, I think, from Vito for commercial clients. So the whole accounting of paying for things, they sort of handle over Terrascope. And he said that to me at some stage, hey, you have to sort of flag on, if you do larger things, you have to flag that you are Terrascope something. So that this works for me, but not for everyone. But it doesn't seem to work for me either. Terrascope reporting. So this, I don't know. Oh, here is something. Sign in. Oh yeah, this one. Signed in. Yeah, so it remembered me. Reporting, I think. Ooh. Ooh. 30 today. Look at that. Credits. Oh, these are the new ones I got, I think. Or usage. Ooh. Yeah, so there's a how's this called? There's a name for this kind of thing. Dashboard. They have a dashboard with your credits, and but I would have to. This is the first time I see this. Yeah, so I don't know where it says what I still have. Right, that would be nice. It's what I used, but not how much I can still use.
I think with the space of the system is a bit unclear how much it costs. Also because of this federation.
Well, they settled that. They know how to pass on bills. They know that, or how to pass them on to ESA. So no, you're not sure. No, neither am I. This is all kind of very early stage. This is actually, as I said, this is working since July or maybe 2 weeks or so. Yes. If I go to billing, available credits. Thank you. And you can see you can buy. This is 30,000 credits in addition for 363. I didn't get that offer this morning. I only got the 8. It's crazy. Wow. So this is a fluctuating market, right? Maybe at some stage you can get money back. If you do things. Yeah, another thing I wanted to because our time is running. Another exciting thing I want to run into is a completely different platform that actually that is also mentioned in the that is mentioned in the slide. So let's, if we have time, we can run through this one and do it because it doesn't take that long. Maybe I should do it. The last example that I wanted to run is Brian's OpenEO. So Brian is sitting there. Brian is right now a PhD student, a former master student that during his master thesis work, he developed an OpenEO backend using R and Plumber. Yeah, because you can, right? Because you can do that. And of course, nobody's going to do high-speed computing parallelized over clusters using R. But if you can, and as I said, if you have something cool going on and want to do it before somebody else does and publish it, and then leave the supercomputing tricks to somebody else, then why not? So this is an example. This is software that is actually published on GitHub here, and it's a Plumber wrapper around a package that actually Marius Appel, another former PhD student and postdoc from Muir, who is still today an employee in my group, but starting in another university as in the professorship tomorrow. An interfacing another package called GDAL cubes, and GDAL cubes is a package that creates data cubes from image collections. Yeah, so the problem of having messy images that are everywhere, different tiles, and have sort of a nicely unordered time format that you want to sort of cube to a larger area, maybe lower resolution, with a particular spatial aggregation method, and to a certain constant or whatever predefined time sort of order. That problem is really common. It is kind of creating ARD in some, and to some extent, if you are interested in temporal changes. That's what GDAL cubes does. And this task was to have an OpenEO sort of front end for that GDAL cubes back end, right? So have a creative web service. And Brian did that very nicely, and also Dockerized the whole container, luckily, so that it's extremely easy to install. And also as an experiment, had it running on large data set on Earth on Amazon. That means on AWS servers in US East, West, US West Oregon, where all the Sentinel-1 and 2 cloud optimized JUnits lie. Yeah, that means if you're running this Docker container in that cloud, you don't have any data transfer, right? The data is in the same data center. So it means it might be 3 meters away, but that's, it is fast that you can get that fast, right? Might not be, it's not on the same node, but it's very fast. So you can do extremely the global computations, so to speak, on the global archive with your own software there, if you rent one of these machines. And actually, as a preparation for this course, I did that. So I did this Docker, and you can also run this locally. I ran this locally. So here I first pulled this Docker container. I think if you don't pull it, it will do that automatically for you. And then I ran it. So, oh no. It's maybe the address is already in use. I'm running it somewhere else, another. I'm sort of running 2 things on the same port. Here I do that, 8,000, not a good idea. So kill that one, see if it now works. So yeah, so it's starting, and you can see it's running on localhost port 8000, and I open it and I get my, my sort of endpoint / yeah, this is the API, what the API says. If you ask it, it's at endpoint, right? So it gives all the standard fields back and says these are the endpoints that they have. So it's self-descriptive, right? And it should have, does it have this documentation also? With __. No, it doesn't say so, but anyway. It should have this Swagger documentation and so on, but anyway, you can find it somewhere else. So we have this thing now running locally, and there are, you know, 1 or 2 images included in that Docker image that you could now process, or you could think about having more images on your hard drive and running a stack on your own machine and sort of telling this Docker image that your stack endpoint is there, and then run things locally, process them locally. What I did is I rendered one of these T2X large machines, which means like whatever is something like 8 or 16 process threads and 16 gigabytes of memory, moderately, you know, moderately sized machine that has something. And I ran this Docker container on so I ran this Docker container using the IP4 address under which the Docker container is known externally, and it happens to be this thing. Yeah. So here you see this is the machine on AWS that I rented, and where port 8000 is exposed and runs this OpenGeoHub process. Right. So I have my own backend now. Yeah, and that is something that, you know, it's a pretty powerful machine in the sense of as powerful as this laptop, but probably with, you know, better hardware, I guess, because it's in a server room, not you know, not in a sort of piece of plastic. It's so what it is cost, right? So it's like I forgot what it was, but I think on a monthly basis, something like whatever, 50, 60 euros or something like that, right? So if you think what a laptop costs, right, and sort of you use it 3 years and divide it, this is not like, you know, crazy amounts or so. It's a you know, feels like a lot of money. We think that a lot of things should be free, but if you can get, you know, projects done that way, then and sort of have a project that pays for those bills, then it's a good alternative. This, of course, has a limited number of processes that it offers, and we will run the process here. Let's do that in our studio. So this was the other case. Come back to. This is it, right? Okay, so, how do we? It just goes back to the R prompt. It was on the Python prompt, it goes back to the R prompt, great. So I connect to my Amazon instance, which I nicely opened for the rest of the world. Please don't touch it because it doesn't do parallel computing. It's very unsafe. I can list collections, and you see here, is somebody else working on this server right now? I had hoped that things would work out here. Yeah, there is something. Oh, do it again. Yeah, login successful, collections. Okay, collections. Collections, you can see Sentinel-2 to L2A, L2A, and Landsat 8. Those are the collections that it has. Yeah, pretty large data set, global, cloud optimized UTIFs. Description of Sentinel-2 and so on. I get the processes. The processes is a limited set that you can look at, reduce dimension, filter spatial, filter bands, filter. So it's not, so you can see this is a very much more limited set than the OpenGeo Cloud backend has, right? But this is just to get, you know, to get certain things going. Here we can describe processes, and I think describe processes should open a thing here, but it doesn't. Oh, I have my new process here listed. I had hoped that this would be where is this? anyway, yeah, load the processes, load connection with a spatial extent. The task here was to for a small area around this new Tesla factory, right, south of Berlin, to see what's going on there. Yeah, if we can detect the changes there that happen, we look at NDVI time series, but we'll do a change detection here that uses the library BFAST, which is an R library, which has a change detection algorithm in it called BFAST that Jan Verbessel developed a long time ago. That is, that is a pretty sort of intricate, complex algorithm that uses all kind of, p-values of cumulative sums of residuals to find breaks in time series. And that is basically used here in its raw form, in the sense of in its R implementation. Yeah, so we are passing an R function here, a function that is called a UDF. Yeah, we passing a UDF here, a user-defined function. So that user-defined function are never OpenGeo processes. They are basically native code. Well, native, they're written in R or in Python. If you have another interpreter, it can be in Julia or whatever. Yeah. So this is what we do. I think we did that. And then we say change detection is this function. So I have a change detection function, and then I have a run UDF process that takes that function, takes that raw R function and moves it to the server and runs it there. List the file formats, save the results as netcdf, and then run them. I think this does it, right? It's now doing it. Compute results. So I can go to the server and see what's going on there. So I logged into the Amazon server now, and I can run an htop to see what the server is doing. So it has 8 threads, and they're pretty busy, as you can see, right? You can see that it's now running 1, 2, 3, 4, 5, 6, 7 R processes. I think GDAL cubes does that, right? Or is that your Plumber? The package does that, right?
Yeah, GDAL cubes.
So GDAL cubes takes care, looks at the number of nodes, threads, cores you have, and parallelizes your problem, and it uses basically the whole resources. An interesting thing that I found out, that is why I didn't invite you to do this, is that currently the way it's set up, if I do this and you're going to do this too, you have to wait until I'm done, right? So this is not like set up in a way that typical web services, of course, accept many connections, it will kind of distribute that and whatever, do port forwarding or something like that, and handle that, right? So that is not handled. This is a typical software engineering task that you could do that has nothing to do with Earth observation, but with web development, right? So you could easily do that. I could also set up like 15 servers and have something in the front that, that puts you to one of these 15 servers that's not busy, and do the whole Kubernetes circus and so on. But that's, that you have to have that should be your hobby if you want to do that, or you should rent some cloud engineer for doing that, right? So it can be done. It's just not something that we did. It's also unsafe. It is HTTP. It's not HTTPS. It has no password and authentication stuff. But it's a proof of concept, and you can do this, of course. Yes.
I was actually wondering, how do you debug, for instance? Because I mean, it looks like if the function already has to be at a certain level, but it's already working. But I mean, usually, start somewhere, and then usually it's not working. At least my case.
Yeah. No, excellent question. And we have thinking about that, for 6 years or 7 years since the start. Like, how's this? Because the error messages that you see are quite often not so extremely friendly, right? There might be a little hint where you get a sense of direction, but it's not real debugging. So that is one of the reasons why we do things like this, because you can sort of take them apart easily. Another way of doing things is by another way of running OpenEO local. I could run this locally by running the Docker image and interacting with the port. I can also do it by just installing the package, GDAL cubes, Plumber, OpenEO cubes, and running it. And then I can see more, right? So of course, there's the web interface that's always a little bit hard to debug, and you may have to use print statements. But you can also do the functions that you're calling and call them from the R prompt, because in the end, that's what's happening, right? You can sort of cut away this web middle layer if you don't like it. So so this is one way of doing this. Is also one of the reasons why we do experiments like this, so that you can have the ability to debug it. You just have to go through installing the functions locally and run them. Of course, there's the issue with possibly with stack, right? That you may want to have run locally a stack instance with the images that you have locally, but that can also be done. Another activity for running things locally is that the Xarray Dask stack that EODC uses can now also be installed locally and used. Yeah, so this is what is also used a lot in active projects that developers, Michele and Peter and so on at URAC use that on a daily basis and sort of develop things locally. And then if it works, they push them to the EODC cloud for sort of large scale computations. So that can be done in principle with the whole Vito setup. You can do it as well on paper. I don't know if anyone ever did it, right? Because they are using a Spark cluster. Yeah, so you have to set up Spark locally, which can be done, but it's not for everyone, right? So this is like that is, and they use containers that are sort of minimized in size and that use local repository. Willing to help you because they like it, that things are being tested and used and taken apart and so on. So right, then there's the thing with UDFs, which is of course fantastic that you can do everything right on the pixels and on the pixel time series as you can do here, which you absolutely can never and will never be able to do on Google Earth Engine. Planetary computer is possibly another story because you run actually notebooks with Python, right? So you could probably do actual Python functions on dimensions and so on, as long as Xarray supports them. The disadvantage there is, of course, that you're creating solutions that are limited to the number of platforms that they work on, right? Because you depend on assumptions. For instance, the assumptions that the backend is running Xarray, because otherwise it will not run. Yeah, that might be an assumption you will have to make. Here with the R backend, we have a function that the backend has to understand, and other backends may not run R at all, or may run R but not understand the way we did it here, right? So those are challenges to sort out. That is more difficult if you go into UDFs. It's more difficult to make that work everywhere. It's just more difficult. That's it. Yeah, and that is sort of still very early. But if that catches on, then it might sort of start working as well. As you can see here, my screen is blank, so the function must have been done now. Where did I do it? Our studio, yes. So that timing. Well, I just was not very good at timing this. I can now sort of load this thing. So read this netcdf file. I had to modify it a little bit apparently, and I can plot it. Well, it doesn't work. Well, I show it what I. yeah, so here is the image that you get out, where you see indeed sort of a lot of non-change values and an area where a lot of change happens, which corresponds to this Tesla factory. The magnitude of change you can also look at, where if you plot that simply with the linear color breaks, then you get completely mistaken. You see a small area here, which is agricultural. If you plot it, however, using quantile breaks, thing that I've been talking about before, you see a much more differentiated image with a crazy color legend that nobody can read anymore, but also with a very clearly designated area where this Tesla factory is being built. So where a very strong land use change is happening. So we can basically observe from space these kind of drastic changes over a longer time series using breakpoint detections. Right. So the last thing I can do is quickly go through this, just as a proof of concept, to go through this other exercise with the data with this. Oh, there's a much smaller set of image collections available on the data space, as you can see here. Oops. Yeah, I thought I had here done this. Yes. Okay. Right. And then go through. There is my process viewer. Here, finally, is my process viewer. That is what I wanted to see. So this is a process viewer that we had in a website that is also integrated with RStudio next to the collections viewer here. And that is also integrated in Jupyter notebooks, same way. So these are just kind of widgets that you can throw into interactive environments like RStudio and Jupyter notebooks. Oh, I hate this. I hate this. RStudio is just such a waste of time. This is incredible. But let's see. Yeah. I could have, of course, clicked the play button. I should have done that, right? So this is working. This is working. Oh, date span not known. Why not? Date span. We should run this whole chunk. Anyway, I think I'm not going to finish here in time. It's going to take 5 minutes anyway, but it should run the way it is shared with you on the website. There is also the little Python file that I shared as a file ndvi.py. If you run that, make the extent a little bit smaller, then it will take less and it will not burn your entire sort of starting credits on OpenGeoHub. So that would be a good idea. I can still change that before lunch. Right. So are there any questions? We survived. I'm sort of, I'm really, wow. This is. So, could you repeat?
Is it possible to Are there processes where, or I need a different function where I can combine data with that? In different collections?
Different collections on the same backend. Different collections on the same backend, you can. Yes, it can combine data cubes. Yes, as long as they run on the same server. With the problem of getting data from different clouds together is pretty large still and not entirely solved. We're actually working on it because this is, of course, you know, the ecosystem and so on suggests that, right? Well, we have these clouds and now we have one front end and that takes care of everything. The problem is just very, very complicated. That if you do a computation here and a computation there and want to combine the results, that is not yet easy.
But if they are in the same backend,
Yeah, then you can do it. You can combine different things. You can combine Landsat and Sentinel, Sentinel-1 and 2, and so on. People do that all the time. Yeah, good question. Yeah, so what I do is sort of, you know, really sort of baby steps, but you know, Vito is running this in production to do their continental crop classifications with using neural networks to whatever, combine all kind of as much as possible stuff from different sources to just, you know, do a sort of a hard classification problem.
Another
Yeah.
Question. Let's say that there is a process not in the capital, and they
Yeah.
would like to propose a
Yeah.
new process. How does it work?
Right, so you can bring this up at I would sort of first bring this up at the user forum and explain your problem, what you would like to do. And then somebody may, you know, ask you why you need it for, or what exactly you're trying to do, and suggest you that couldn't you do this with using these two processes combined or something like that, right? Or maybe they may be tempted to implement it if they think this is a fair question and is a useful extension. Yeah, there's a lot of resources. There are software engineers expanding this on a daily basis. So bring it up, join the user forum. Yeah. Any other questions?
I would like maybe a small clarification, but just trying to understand how this works. So you can make your own server, as you were mentioning.
Yeah.
Your own server, your own API, and then you connect that with OpenGeoHub. Then how does it work in the side of OpenGeoHub? Like, do you like combine all the data in your own server, or it's or you redirect it from that API? So what's the
So it depends, right? So the data should be on the server, right? That's the assumption. If they're not, you're going to do a lot of network traffic by reading them, copying them. And the interface is over stack, right? So OpenGeoHub builds on stack, right? The assumption is that the data that are there can be sort of found and selected through a stack interface. Yeah, that is step one. And then you can sort of build on what you're going to do with these data and how you're going to combine them. And that is the processes. That's what the processes do. Yeah. So I was thinking the two collections, there is a command called merge cubes, where you basically create sort of a new sort of cube that sort of merges Sentinel-1 and 2, which is a little bit abstract, sort of an abstract activity, because of course they're not sort of really matching in terms of the type of information they have. But nevertheless, you want to combine it and reuse it later on in some way. Right, so active sort of areas of active research are now making this this is the sort of modeling that we show is quite often sort of forward modeling, right? Where you know the steps you want to do, and inverse modeling, training models, machine learning, and so on, training machine learning models, applying them to predict things are kind of next steps that are in an experimental stage, but that they're kind of will be developed in the next few years, since we have a lot of resources for doing that and made promises for doing that, actually. Yeah, so that's what Brian's going to do. So check Brian for lunch. Yeah. Yeah.
Feel free to reach out if you have think my email will be.
You'll find it. Good. So thanks everyone for joining and holding out with me. Yeah.
And if you lost something, we have it video recorded